Hello, Nathan, is my voice audible?
Yeah, I know, I can hear you.
Eh, So, could you just let us know about yourself? Where do you work and what do you do? And a bit a self intro of yourself, if you don't mind.
Cool. So currently I work at ZS. Um, it's a consulting firm which does consulting work for mostly healthcare domains. But then before that, I just gave my background. So I did my um, PUC, like pre-university first year and second year in Karnataka. I'm a science student. Post that, I studied engineering in Bangalore. I went to MS Ramaya. I did my engineering in computer science. So I graduated in and around 2015. And then I worked in ISRO for about 6 months. That was my final year project. So I worked as an intern in ISRO. Um, so I worked on this project where it was in the data domain itself. So probably I think it just hit the data from me at that place, but we were working on the data you receive from satellite. If the satellite moves in particular direction, so basically we do fault tolerance. If the satellite is moving away from the sun, we try to rotate the direction of the satellite to get more energy from the sun. Do some fault tolerance, run system level checks, so all kind of that. And then after that, I worked in banking domain company called Temenos. It's a software product where you build software for banks. Basically, a banking system like Oracle has a Flex Cube, like Temenos has T24. They are quite established in European domain. So I worked in the payments domain as a software engineer for about a year and a half. Um, and then after that, I came to US. So this was around 2017, and then I came to US in 2017. I did my master's in data science. I went to Rutgers University here in New Jersey. Um, yeah, I mean, in 1.5 years, I think I just studied like what you guys are studying basically. But then back then, R was too interesting, although I never got the gist of it. But most of the people used to code in R back then, but I used to code in Python. So Python has been my bread and butter since then. But most of the courses I took in Rutgers were like AI, machine learning, um, like Python programming, data mining, and all that. I think it's the same coursework for people who venture into data science, I feel. And then after that, I worked in healthcare domain uh, as a data analyst first. It was difficult to get as a data scientist in the beginning. So I chose this data analyst. I worked as a data analyst for a year and a half, processing sales data and claims and healthcare data for the Bristol Myers Squibb pharmaceutical company. Um, and then I moved to Cali. Uh, I got a job as a data scientist in the company called Ectana. It was also in the healthcare domain. Um, so we are basically helping reps reach out to doctors using AI and machine learning. So we used to predict when the doctor is to open the email, or we used to predict like which rep is closest to the doctor using lat long, and and disclose the next best action the rep would take. So yeah, basically AI and ML in the field of sales reps and commercial analytics or commercial pharma. Um, and then after that, I worked in WebMD for a few months as a data engineering manager, but then I didn't like this managerial role much. And then I moved to consulting now. So as a data science consultant. So it's been interesting. So let's see. And
I
I'm
got
currently,
it.
yeah, so I'm currently working in New York City office. I stay in Brooklyn.
Oh,
Uh, yeah, I think that's pretty much it. I'm not sure
uh,
if I went too deep into it, but yeah.
No, it's fine. You did mention that you worked in ISRO regarding the movement of the satellite and the sun, right? Was it a
Mhm.
static data or was it a streaming data that you worked on?
So generally, it takes around 6 months for you to get the data from satellites.
Oh,
It's not real time for sure.
I'm sorry. Okay.
So yeah, but we were not working on like real time satellite data, but ISRO generally they save a lot of data. So it was j- it was all the data which was saved, but then it had a timeline attached to it and a path where the satellite uses the trajectory path in the space. So we literally read the data one after the other. Um, I mean, one after the other. I mean, it's a timeline, it's a time series data. So it's not real time data basically. I know.
Thanks.
Hi, Nitin. Sorry, I think my
Okay.
mic was on mute when I joined the call. I don't know how it got
No
connected.
problem. Yes,
Yeah, too embarrassing. But anyway,
no.
so our project is, I mean, the course is basically on big data. So we probably will be asking a lot of questions specific to big data.
Cool.
Yeah. So I just wanted to know what's the
Mhm.
um, project life cycle that you have been involved in. Like, how do you create a life cycle and what all tasks you assign in a normal project?
Um, in the realm of data science,
We'll
right?
get the cut off back. 2 minutes. For 2 minutes.
So sort of in the realm of data science, you meant, or in just general in my current job?
I mean, whatever you have encountered in like when a project is assigned.
Oh, okay. So in the realm of data science, and what was your question? Sorry, I forgot.
Like,
Um,
what is the project life cycle
oh,
that's generally been used?
okay. So I worked in, so when I worked in Actana as a data scientist, so different teams have different structure. Specifically in data science domain, they have their own life cycle of project. So some projects, like when you do consulting firm projects, where you work for a client and you have a set of timeline that you need to finish your project, build the model. It's pretty much like the iterative way. I think there's this waterfall, and I'm not sure what was the other one, but it's kind of similar. It's not the traditional software engineering life cycle. It's the
Mhm.
data science life cycle where you collect the data, clean, manage, pre-process, and build the model, visualize the data, and then continuously improve the model. So that's pretty much the basic in every data science domain, and it was in our Actana as well. But then in Actana we did things little differently. Like initially we all went and focused on collecting the data, mining the data, using feature engineering to generate features, and have this one huge hefty data set of 800 columns. um, and we built this whole data set from
Mhm.
scratch, and then we use this data set for various other machine learning models.
Yeah.
So yeah, so it's slightly different in different companies, but then right now it's becoming normal now. Like you have a data science team and you have a machine learning team, and you generally talk to machine learning team, you build models and give it to them, and they will productionalize them. So
Got it.
Hey,
Nitin,
Nitin, how are you?
mhm.
Yeah.
Yeah, please go ahead.
Yeah. So my question was, what are some of the biggest challenges that you face in bridging big data engineering with data science, and how you overcome this at these CS?
uh like challenges in big data
Yeah,
and
in bridging data. Yeah, data
like
engineering with data science. Yeah.
okay, like in general, what you come across or encounter challenges when you process big data
Yeah.
in the realm of data engineering and data science.
Hmm.
um it See, actually data engineers are called the plumbers of the data science domain, like
Mhm.
we set up the platform, we 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 get our hands dirty, is what I would like to say. When I say that, you actually go and work on the crux of the data, like generally, any data you get is not cleaned. So data engineers are the one who get in there and clean the data, pre-process it,
Mhm.
take off the, I mean, basically clean the data inside the platform for further people to use it. So in that, you have a challenge of data quality and inconsistency. You need to be very patient when you deal with a lot of inconsistent data. And you have, right now, data is oil, right? I mean, they've been saying this for like 2 years now. And you get different formats of data. You have
Yes.
uh, different processes, different types of data you get from different various sources. You have different real-time issues when you're processing real-time data or you're processing batch data. So the inconsistent data formats and errors, those things you need to fix in. And when you integrate all this data from various different sources, right? How do you bring all that data in one platform and you transform and load it in this big data system? So that data integration engineer is a new term. So getting the data, integrating it, quality checking it, and having the data consistently giving it to a machine learning model is a big task for data engineers or big data people to fill it in. And then
Mhm.
it comes, so once this was on the extraction part or transformation part or loading part, like the ETL part. So in and around, you have data volume changes, you have exponential growth of data. When you manage and store huge volumes of data, that can be a problem. How do you scale when you have this much amount of data? Like you have billions of rows, so how are you going to process and scale that data? That's pretty interesting, and it's not that easy for you to process billions of rows of data regularly, right?
Yes.
Yeah, and then governing the data, providing security to the data. So overall, these were pretty much the challenges, I would say, in terms of big data or data engineering in data science. I didn't go too much into data
Okay.
science, but yeah.
Okay.
So I in Akansha this side.
Yeah.
So I want to talk about like have you ever got a chance to work on ML pipelines where we work on the
Mhm.
Airflow and all these
Mhm.
technologies?
I did work on Airflow and MLflow both actually.
Mm-hmm.
So Airflow is generally used for orchestration.
Mm-hmm.
Like when I said this ETL, right? You
Mm-hmm.
have data extraction, transformation, and loading. So in Python, when you do all this, you just use Airflow so that you can visualize your whole ETL pipeline. Like for example,
Okay.
you have multiple different data sources coming in. You're doing some transformation, you're cleaning, you're joining multiple data frames. So you can visually see that as a DAG. I'm not sure if you know
Okay.
DAG, but it's a directed
Yeah.
acyclic graph where you actually see the whole, yeah. So it's basically very helpful in debugging the whole pipeline. You would know where it exactly goes in
Okay.
mistake. So yeah, so Airflow, it's for orchestration, like scheduling and monitoring the jobs. The only thing I like about is that UI and you can use Python to write that Airflow code. So in that way, that's pretty neat. And for MLflow, it's again the orchestration part, but for machine learning models. Like once you have data collection and pre-processing where data engineers work on Airflow, you have the data cleaned and ready to be used for modeling, right? And
Mm-hmm.
once you do the model training and evaluation, you use MLflow for packaging and deploying that model on the AWS server, or it's just an orchestration tool where you can schedule the model, train the model, integrate integrate this MLflow pipeline to like AWS, deploy the whole thing on AWS. It's just another tool like Airflow, but Airflow is only for data collection and pre-processing, whereas MLflow is for model training, evaluating, deploying the model, and then monitoring that model, all that. Yeah.
Okay. So like as we know, like big data having works on large data set, right? So how complex it is to bring insight and making the decision, like what are the key metrics that we see generally to make the decisions, business decision that can help the business? Yeah, that's what I want to ask.
So like how do you how do you extract insightful information from big data?
Yeah, like the key metrics, like we can make multiple insights from the data. We can make multiple visualizations and look into the multiple factors, but what are the key metrics that basically data scientist, as a data scientist, one should stress upon?
So in the general way, let me see if I can answer your question. So you can, if yeah, I think you also need a little bit of perspective. Like the same data can be answered in multiple ways. So I would say asking the right questions to that data is very important. I feel, Akash, because many times when we looked at this big data, right? So you have billions of rows, you have thousands of columns. You need to know what you're looking in first. So you need to have those questions, right? Like have a clear objective or some sort of like, for example, you have a lot of customer data. You would know what problem you're trying to solve from the data. You're trying to increase the sales. Now try to put those questions on that data, and data will give you the answer. So in terms of that, you would do data exploration. So many number of times having a clear set of objective or a problem you're looking to solve would be very helpful when you look at not just big data, but in general, the data. They call the 3 V's, like volume, velocity, or I don't know what was the other one, but generally in terms of volume or velocity, whatever it is, I feel having a clear objective is quite helpful. Yeah.
The third one is veracity, by the way.
Oh,
Yeah.
velocity. Okay.
Cool,
Yeah.
cool, yeah.
Hi, Nitin. So, if in case you will be, so generally when we work for a company, we will always be given some business requirements or a data requirements that would be the new, something new that rather than the existing one, right? Uh, just give a small example, like performing an ETL pipeline where we generally perform it manually. Even that is also considered as a business requirement in the when we are working for a company. So like when something of that sort is given to handle a large data or something like that, do you usually perform on a sample data set, or how do you do it? Because this is because generally for a static data set you consider CSV and you check the files and all, but for streaming that is not how it works. So how do you do it for streaming?
For real-time streaming, generally when you do the ETL pipeline, I mean, the most important thing when you create a ETL pipeline is you don't process it on billions of rows or construct the ETL pipeline on billions of rows. So you just filter the data, fit the data in the RAM, use a single machine to create your whole pipeline, filter the data out to very, not thousands, but at least millions, which could help you create that pipeline pretty fast and neat and clean. When I say filter the data, not filtering like the columns, but filtering the bulk of the data, like filtering the rows, so that you would expect a similar kind of data when you increase the size of the size of your cluster or the RAM or the compute power you're processing. But generally, what I used to do is I used to build my whole ETL pipeline from the beginning all the way to the end on very few records.
Okay.
In that way, it won't first of all, you don't have to wait for every code when you run, and you can solve different kinds of errors in the whole pipeline, and you can just not just concentrate on the processing, but you can also concentrate on where the data is getting filtered, which process is taking a long period of time. So so I would just look at the time it takes to process for, let's say, if I'm processing for 10,000 rows, how much time would it take? And I would exponentially calculate and see if it would take the same amount of time when you have billions of rows of data. So I would say filter or random sample on the data which you have, build the whole pipeline, even though if it is Kafka or real time.
Okay.
And then once you have the all data coming in, you increase the compute power to process that data.
Just, thank you, Nitin. This is just one question.
Yeah.
This is all under the assumption that the entire data has the same flow or the same structure, right?
Right.
There are many cases, especially you did say that you did work under the telecom industry, right?
Telecom.
I'm sorry, did I hear it wrong?
No, but it's fine. Yeah, please go ahead.
It's just that in telecom, you'll be if we consider any of the records, they will be having some bad records or some structure that is out of the usual. So do you already keep the check your file ahead, or how do you handle that problem? Because this is under the assumption that the entire file has a similar structure and there are no errors in the file.
Right. Yeah, I mean,
That is not how it works in a real
time.
Yeah.
Yeah. So initially, I think you have a set of quality checks before, in the beginning of the pipeline. You would obviously look at the column structure, the data type of that columns is exactly same as what you've been processing in the past.
Okay.
You would check for missing values, if there is any outlier, or I think you do all that basic checks very beginning in the pipeline. Before and raise that red flag when you have the data coming in which is not correct. So you have quality checks. Yeah, we have quality checks built in the very beginning. Although I don't like too much of doing data quality checks, but then
because you cannot exactly expect what kind of a different structure you have for each file. Every time it's going to be a new error. We cannot actually predict it.
Exactly. Yeah. So you need to have those data quality checks in. I mean, that's very important, even just when you're processing the data in the realm of data management or data science or data governance or data security, you need to have those data quality checks.
Have you used any ML model?
Sainath?
On the streaming data particularly?
I did not work too much on the streaming data.
Okay.
Mostly I worked only on the batch processing part. In healthcare, there's not much of live streaming data which I got the chance to play in, although I would love to. But yeah, I mean, I've used Kafka only on like a school project or anything. But I don't have too much experience on the streamline and real-time
It's
data.
fine. You can just let me know on the batch processing. The thing was, it was just a recent assignment was on streaming, so just my head that's been focusing on streaming. That's it. I'm sorry.
Okay. But so what was your question? Like,
just that have you implemented any ML models on big data, on like large sets of data?
Right. Yeah, so when I was in Actama, we built this model called channel propensity model, where these reps talk to doctors using different channels, like phone or email or face-to-face, virtual Zoom, or meeting them outside. So we're trying to predict for this rep what are the high chances of meeting this doctor using what channel. So it's to predict the probability. And now for this, we build this machine learning model on Pfizer Japan. Pfizer is a pharmaceutical firm. So we built on that Pfizer Japan dataset, a pharmaceutical firm in Japan. They had limited records, not too many. Like they have limited doctors when compared to US. So we processed the whole machine learning model. We created that. I'm not sure if it is called in the realm of big data, but then when you build a prototype, you generally work with a small set of data, as I said, randomly. You do the random sample and build your model. And then once you start training and evaluating the model, you get all the data set in. But then when you productionalize it, that is when you use like PySpark. So you have machine learning models written in PySpark where you actually train a model in parallel. So it's since you again can't fit the whole data in the memory for you to train a machine learning model,
Yes.
especially in terms of textual data, or when you have neural networks with a lot of deep learning layers connected in. So you would train different layers on different streaming, different compute power. Now, generally these days, everything is being on cloud. So, you don't need to actually do like how people used to do in Hadoop, where you actually split or do a cluster or anything. These days, everything is being on cloud, so you just increase the compute power.
Okay.
And so once you increase that compute power, the AWS will take care of running that whole model in parallel or splitting up that whole job. But then, yeah, so when we did this whole thing on Pfizer US, they had around millions of doctors, and we had around not very close to billions of records of transactions between the reps and the doctors. So we deployed this model on Spark EMR cluster. We triggered the EMR and then scheduled that job. Yeah, so I worked on this.
I'm sorry, what was the ML model that you used?
So we used different types. So for face-to-face, it was XGBoost.
Okay.
Whereas for virtual interaction, it was, I believe, neural networks. But then every channel is different, right? Every channel has
Yes.
different set of features. So it depends on the data, it depends on the probability of predicting in the columns and the scenario. So there were different models for different channels. So,
You have worked both as a data scientist and also you have a bit of you have an experience in big data as well. So how do you say like how do you what is the difference like in machine learning, like doing in a machine learning model, training a machine learning model in Python and doing a machine learning model in big data, that is PySpark? What is the major difference? Which one would you prefer out of the both?
like using Python versus PySpark for machine learning model
Yes.
development.
Yes.
I think generally I've seen data scientists working on pandas
Yeah.
or NumPy. But although now because of deep learning and all that, people are using like TensorFlow, PyTorch. But generally what I've seen is machine learning engineers who they are the one who's responsible for deploying the model in production and all that, right?
Yes.
So they are the one who actually work using Spark, PySpark, and productionalizing the machine learning model. So I worked with machine learning engineers. I did not do hands-on coding in terms of deploying the model, but development using PySpark, I played a little bit. I mean, they have similar kinds of libraries, like how you have sklearn for pandas, right?
Yes.
So you have different libraries for
PySpark as well.
PySpark, right.
Because I'm like I'm having a new assignment where I need to work on training a model. So I thought it was the structure was completely different. So I just wanted to know what is the major difference between them. That's it.
I think it's quite similar. I mean, it's same as how you process the data, right? You have different API function calls. Like in
Okay.
sklearn, you import a linear regression and then you use .model.fit.
.fit, yes.
So in ML, like in the Spark also, you have the same thing. It's just that you're doing it on a Spark data frame, basically. But then, yeah, debugging and all that is a little complex in Spark.
Okay.
But then, yeah, again, it comes with a lot of problems because you're trying to split the data in, trading the data in parallel on different compute power. But then now, because of AWS or cloud, everything has become very easy to develop and deploy the models on cloud using. I mean, the compute power is so easy to get these days. Not sure about the money, but yeah.
Hi, Nitin. In your LinkedIn was written that like you worked in a project that uses random forest and gradient boosted trees on sales trends. So how do you actually manage the scalability of data? Because I think the data will be so huge and it's going to be
Yeah.
flowing. How do you manage scalability of it?
So generally, yeah, I mean, we at least for that project here, it was on a small set of data. We never had issues with the scalability, but then these days, when the clients are, using Databricks, AWS. So for even data scientists now, they have already a notebook on cloud where they can increase the memory size or the RAM or the compute power. So people generally, I mean, when I used to work back then, I used to just create a cluster for 8 GB first and then process the data on like 50% of the data, process the machine learning model and see if there is an overfit over RAM issue. So you do like multiple tests on the size and the RAM, but then it's just a very basic mathematical calculation, I think, sort of like how much data you're processing, how much RAM you have, what is the compute power, how complex is your machine learning model. Like for example, decision trees needs a lot of space, right? Because they just have a lot of features for every row. So and for random forest and XGBoost, I know they're quite complex than decision trees, but then you need a lot of space. So we used AWS in terms of scalability. Now, when you have AWS, it doesn't mean that you can just use any amount of compute power. You should try to save the cost as much as we can right now. Yeah. So I think we managed, we just went on multiple iterations and see which is the best RAM size or compute power for this machine learning model to be in production. Just hit and trial. So I think that's what I have seen most of the people doing it. You wouldn't know unless you process the data and build the model and see how much compute power it takes.
Got it.
Nitin, have you by any chance worked on, like, have you come across a situation where you need to work on sliding window technique or DGIM algorithm or anything like that?
Sliding window, when you mean like processing the data using
yes.
Windows functions? Like those window functions, right? Sorry.
No, actually, I mean, like when you take a batch of data, when going through the batch of data,
Oh.
in that sense, I'm sorry.
Oh, okay. Sliding window in terms of like data drift,
Yes,
those kind of techniques. I did work on data drift a little bit. Like generally we look at the drift. There's a concept called, there is a term called concept drift.
Okay.
So you look at like different statistical computations, like you look at the correlation, or you're looking at different I wouldn't say KPI, but it's a metric where you measure on how your data drifts in that particular time. Now, that particular time can be different. Some people would be look at week over week. Generally, these drifts might be helpful, like if there is a pandemic and then suddenly, the whole world stops, then you would see that differences in data. So now if you're looking at week over week or month over month, you have some metrics built in. Then when you have this data drifts or a fixed sliding window, right, you would recognize when something like this happens, when there is an issue in the data or when there is some huge impact on your data. So when you have this drift or sliding window, fixed sliding window process, it's another type of data quality check you can write, but it has a whole world to it. Data drift is a very fancy term, but they have machine learning models to identify drift in the data. So there are different types of concept drifts, but yeah, that's I've worked a little bit though. Yeah.
Hey Nitin, this is Shashank.
Hey, Shashank.
So it's like, you were explaining that you had 800 columns in your data set. So how you are gonna take out the important features? You are using any dimensionality reduction techniques for this?
Yeah. Uh, we I remember we did use PCA. Um,
So
and
because
then
you
Mhm,
said that it was a hospital data, it's like sometimes the data will be linear and non-linear. So
mhm.
regarding so it's like how you people handle the non-linear data and the linear data.
Um, like firstly, for the first question you answered, first question, I feel like when you have 800 columns, you can easily filter out. I mean, we had this 800 columns where we built in for, and on top of this, we had like around 50 to 60 different types of machine learning models running on it. So, so you wouldn't really know which feature is important for what machine learning model. So generally, you start with very subset of features and gradually keep adding the feature in without overfitting. So we used like regularization,
Yeah,
like you do L1, L2, or what,
L1, L2, yeah,
those
yeah.
sorts of regularization to just see what features are important, or even in the terms of like random forest. Not sure if it is random forest or XGBoost, which gives you how much the feature is important. So you can look at
Oh,
this feature importance on basic machine learning model after doing regularization. And
okay.
then, yeah, once you know a few set of features which are important, uh, you would you would select those features and then those similar features in that same domain or a context. Like for example, you have a feature in terms of doctors, specialty is very important. Then you would look the features in and around specialty, like what determines specialty, which attributes affect specialty. So we select those features. So it's a mix of different techniques, Shashank, like
Okay.
PCA in the beginning. You build a rough model of XGBoost or some sort of other model which can handle good regularization and decide which features are important. Um,
Uh,
and uh, and
and
your
also
linear
I want, yeah, sorry, you're saying something.
Yeah, for linear data and non-linear data, I think yeah, for non-linearity, you generally use like neural networks or deep learning,
Oh,
which is pretty good in terms of non-linearity. Linear, I think it's very straightforward. You use any regression techniques. You don't have too much to do. I mean, you can still use neural networks and deep learning for linear data, but then it's mostly used for non-linear. You have a very complex set of functions you need to identify. Then I would say, yeah, deep learning would be very helpful in that.
and also I have a question. It's like, what kind of tools are you using for the entire data pipeline? Just like for the data processing, and it's like you said you are using the PySpark, and for the and you said like Amazon EMR. It's like what was the other tools and technologies you've been using in your project?
Uh, so, so we used this notebook called Zeppelin, and I mean, the whole point of us was to reduce the cost. Say AWS SageMaker is very expensive, where you can open Jupyter Notebook on AWS using AWS EMR cluster. But then to save the cost, what we had did was there is another notebook called Zeppelin. So we use this Zeppelin notebook to connect to AWS. So first thing is we used to create this whole process in your laptop. When I say laptop, I mean I had a 32 GB Mac where you can pretty much fit at least close to billions of rows in your Spark. Again, it depends on the data, kinds of data. Like if it is text, then it's difficult. But then, yeah, mostly we had written the whole process in your Mac first to save the money. And then on the tools, we used like VS Code to write code, like VS Code, Zeppelin, Jupyter Notebook. From the AWS also, we used PyCharm to connect to AWS EMR, where you can directly deploy your whole code on EMR using PyCharm by hitting just one button.
Yeah.
And on the
So
AWS,
so every time do you invoke the start button just like to run the entire data pipeline, or whenever the data comes, whenever there was a batch of files coming in, it's like the system directly senses that the data is coming and invokes the whole data pipeline, or every time you schedule, it's like this time you'll invoke it's like we'll start the data pipeline and just like we'll process this data. It's like how you manage this kind of situation,
Yeah,
whether
when you're building it, you have all the data frames in your memory, right?
yeah,
So you can just look at that data frame, you can count on the data frame, you can do group by and all that. But when it's in production, obviously you need to schedule that job, which kickstarts a Spark job. And then you have a lot of debug statements you have written in the middle of the code. So, I mean, yeah, there is start button when you're developing it. You can write one single line of code, debug, and check on the data frame, like how you write similar Python code. There's
yeah,
no only when you schedule, when you're processing batch data, then see, like you have the ETL pipeline, you have 15 to 20 scripts, and somewhere in the middle, like around 14th or 15th script, there is some error. Now, if you properly divide your code so that when you run, this is the one disadvantage of using Python, that once you kickstart a PySpark or a Python script, you can't, it's not a compiled level, right? It's a very real-time, real language code where it really runs when you hit enter. But
yeah,
then you should be smart enough when you write Python code to have it in functions, have a main script like main.py where you call those 15 scripts from main.py, so that when you debug, you have an issue on 14th or 15th script, you can run your script until the 14th script and then use the data frame and processing until then to check what happened after that to debug it.
yeah. Got it. Yeah, that was a great point.
Yeah.
So you people were using the ETL framework or the ELT framework for the data warehousing?
Right now in ZS, we have been using ELT
Uh-huh.
because we get the data from S3, so we extract from S3 using the stage environment and we load it in Snowflake. And then from
Okay.
Snowflake, we transform it.
Oh, okay. Yeah.
So yeah, usually in ETL, you transform the data on AWS from the place where you extract, but we did that in Actana. But
So
now
you transform the data using the Apache Airflow DAGs or else some other transformation techniques like dbt, something like that.
not really. I think we used IICS now. Here in ZS, we're using IICS. But it's not that straightforward. IICS is too complex, I would say, but we're using IICS job to
Oh,
transform. But then Snowflake has been the bread and butter now. I mean, it's the most important tool.
oh,
So yeah, once we load the data in Snowflake and then we do the transformation and all that. So it's a mix of IICS and Snowflake.
yeah. Yeah. Thanks, Nitin. Yeah, that was my question.
Yep.
Hi, Nitin. I just wanted to ask probably my last question. How
Mhm.
do you keep yourself updated with these technologies that are rapidly coming up? I think every couple of years there's a new tool or something that pops up.
I know it's been tough. It's been really tough because 2017 is when I started actually. And back then, I'm not sure if you guys have gone through Andrew Ng's machine learning course on the Coursera.
Oh, yeah, I haven't.
Yeah. Oh, you haven't? I think you guys should. So that back then in 2017, he used to explain in a programming language called Octave.
Mm-hmm.
And I like this data science domain so much that I wanted the concepts what he taught using Octave, and I wrote the code in Python.
Oh,
So yeah, but now within 8 years of span, the whole dynamic has been changed, after ChatGPT is released. So to keep up, I would say just keep reading law. I mean, these days people have stopped reading. Even I have stopped reading. So generally, I have this habit of reading at least 30 minutes before I sleep. But then you follow a lot of different journals. Like you have Open Data Science Central, you have Analytics Vidya, you have Medium, LinkedIn. LinkedIn has been so amazing these days. I mean, there are a few bunch of folks who I follow.
mm-hmm.
They keep posting like different set of articles, different set of trending news, how is generative AI capturing in different sets of market in the next 5 years, how generative AI is going to change what domain. So, I mean, apparently LinkedIn has been very interesting for me in terms of learning, like following at least the news and the trending. I know finding job is one thing though in LinkedIn, but then it has a lot of other things to offer as well. So right now, I mean, my whole agenda, or at least to keep up with generative AI or this whole domain, is to make my profile really amazing, like from LinkedIn's point of view. Try to follow as many people whom you like, join those groups in LinkedIn in terms of data science. Follow a lot of people in the same domain, I would say, like Andrew NG or those set of people. They'll be posting all the latest things happening in the world. So yeah, I mean, you have to be proactive, I think. So that's the most important part. But then once you grow old, you have a lot of other responsibilities which takes your time in. But then yeah, I have this goal this year that for the next coming year, that I'll try to read more as much as I can. I mean, yeah.
Got it.
Okay, Nitin, I have a last question.
Uh-huh.
So we are graduating next December 24. As you know, the market is very bad.
Mhm.
There are more rejections than acceptance. So
Yeah.
it's like what are the companies who are looking at the new fresh grad? It's like for the data engineers or the data scientists. What are the kind of
Right.
key things they are looking for? So it's like we can
Yeah.
prepare on that.
Cool. Good question. So right now, I think back then, resume would be enough, but then now they're looking at your whole profile. Now, first thing, you need to have your own website. So when I say website for data scientists or data engineers or people who are not in the front end or software engineering realm, these days there are amazing different libraries or tools, if you know Python, where you can build your website in 5 minutes. There's this tool called Streamlit I've used to build a website or a portfolio. I think you guys should look at Streamlit. It's pretty basic and you can build a website in few minutes. So having a portfolio, not just your resume, but build a website, like have a LinkedIn, have an amazing LinkedIn. When I say amazing LinkedIn, like keep posting on the articles or whatever you've studied. Follow those people to know like what have been different groups, participate, talking in different groups. Keep posting in Medium articles, I would say. Medium has also been people has been looking at your Medium profile nowadays. So how much you give back also people have been looking at. So having an overall profile would be helpful for you to stand out. Like obviously your job, you can showcase what different types of machine learning models you have built in. You can deploy your model on your website. So any recruiter can come and see what model you have built in. So yeah, having just resume and GitHub account wouldn't suffice, I would say, to stand out. Have a portfolio, like a website or website, not or, but website and LinkedIn and Medium. See if you can publish 2 or 3 research papers. I have 1 or 2 on my name, so that would definitely help. At least my first data scientist job I got because I had published a paper in IEEE. This was when I did that ISRO internship. So see, that I did in 2015. I never knew that that would help me getting a job as data scientist in 2018. So you never know. I mean, so I would say just have an overall profile and a portfolio, talk to different set of people, networking, having those connections would be helpful, I think, overall.
Yeah. Thanks, Nitin. Yeah.
Yep. Thanks, Nitin.
Cool. Thanks. Nice
Thanks a lot,
questions.
Nitin. Thank you so much.
Thank you.
Thank you, Nitin.
I hope you got some gist of the real world.
Yes, it was very
Yeah,
insightful.
a lot.
Yeah. Try to work on good projects. I think that's the most important. try to work on those good projects and then showcase whatever projects you worked on Medium and LinkedIn or on your website. Publish those papers and put it out there, I would say. A lot of people have amazing resumes, but then these days people are so bored. They don't want to look at your resume. They want to see what you've actually built in. So work on that stuff, I would say.
Yeah, that's true.
Okay.
Thank you so much, Nitin. Thank you for
Thanks.
sparing your time.
Yep. Hope you have a
Yeah.
great night and then good luck for your job next year.
Yeah.
Thank you so
Thank
much.
you.
Mind we connect you over in LinkedIn if that's cool with you.
Yeah, sure, please. I think I've shared this profile. Sainath, you have it, right?
Yes, I do have the
Yeah,
profile.
he has shared it.
Yes,
Yeah.
Okay, yeah.
I did push
Add
it in
me
the group
in.
as well.
You guys can add me in. I'll follow you guys.
Yeah.
Thank you.
Thanks. Bye.
Thanks,
Bye.
Nitin.
Bye.
It was nice talking to you.
Same
Thanks.
here. Bye.